Hello students, today I am going to teach you invertible functions. It is a continuation of relational function. So in the last class you have studied about composition of function. So today we will proceed with the invertible functions. So what is invertible functions? So let f is a function defined from x to y. F is a function defined from the set x to y, and it is 1 1 and 1 2. F is 1 1 and 1 2. Already you know what is 1 1 and 1 2. That means in short we say it is bijective. F is a function from x to y and it is 1 1 and 1 2. Then we can define a function from y to x. We will be able to define a function from y to x. That is known as inverse of the function. So we can say that in other way we can say that if we can find out inverse of a function, then the function is invertible. If we can find out the inverse of a function, then we can say the function is invertible. Now when we can find out inverse, the function must be 1 1 and 1 2. That is bijective. That already you studied in the last class. Otherwise just go through the previous video, then you will be able to follow what is 1 1 and 1 2. Okay, so this, if I draw the corresponding Venn diagram of this part, see the function f I have defined this in the two sets x and y. X and y, f is from x to y. Naturally f inverse, and it is f is 1 1 and 1 2. Then f inverse is from y to x. This is f inverse. See, if I take an element from x, that is x I am taking, the corresponding image is here, it is y. See, if f is operate on x, so it will become fx, that is equal to y. And if f inverse operates on y, f inverse operates on y, then it will become, that is f inverse of y is equal to x. F inverse is operating on y, then that means f inverse of y is equal to x. So this is the corresponding arrow diagram for inverse function. F is from x to y, it is 1 1 and 1 2, then f inverse is from y to x. So now if you observe this, we can say that the domain of f inverse, this is the domain of f inverse, that is what? Range of f. Range of f is same as domain of f inverse. That is the first point we will be able to see from this. That is domain of f inverse is equal to range of f. This is one point we will get from here. Another thing, if you observe it, range of f inverse, that is range of f inverse is equal to domain of f. It's clear from the diagram. Okay, the range of f inverse, that is this side, it will be the domain of f. Now another thing, already I said, we know that y is equal to f, for x its image is y, so that can be written as, we can, that is the third point, we can say that y is equal to f of x. If and only if, what we will get? X is equal to f inverse y. X is equal to f inverse y for all x belongs to x and for all y belongs to y. Y is equal to fx if and only if x is equal to f inverse y. For all x belongs to x and for all y belongs to y. These are the three results we will come across from this invertible function. Okay, so that is the domain part, range part, and these three things. Okay, you have to know these three things, then we will be able to deal with this. Now we will discuss about some properties related to this invertible function. Some properties. That means the one property is what will be the composition of a function and its corresponding inverse. That is f composition f inverse or f inverse composition f, that I am going to discuss next. Okay, so here f is from x to y, then f inverse is from y to x, provided f must be 1 1 and 1 2. So based on that I am going to make a composition function. That is the next point. That is our results related to this. So f is from x to y, f inverse is from y to x. So based on this I am making composition function. Say x to y, it is f, and f inverse is from y to x, so I am making once again x here. F inverse is from y to x. Now you see, it is just like a composition. Last class you studied about composition. I can go for the composition of f and f inverse. So that will be the function from here. This is f inverse of f. That is the composition. F inverse of f is from, you can see it is from x to x. So that is f inverse of f is from x to x. It is, we know, a function from x to x, that we say is identity function. We studied that. That is, we can say that f inverse of f is equal to identity function on x. Identity function on x. F inverse of f is from x to x, that we can say identity function. That means here we can see that composition of an inverse function and the corresponding function is equal to identity function. So this is one result I made up, that is f inverse of f is equal to ix. Now one more result we can make out. One more result we can make out like this. Say we know the same result. The same result, if you see it, I am writing first of all f inverse. F inverse is from y to x. Here I am marking f inverse first. It is from y to x, and then I am making the next function to y. Then this is y. Here the function is f. That is, function f is from x to y. This 1 1 and 1 2. So here we can make the function. This function will be what? F of f inverse. F of f inverse. So f of f inverse is from y to y. It is from y to y. See, f of f inverse is from y to y. So in this case, here last case it was from x to x. Now it will be from y to y. What is f of f inverse? F of f inverse is from y to y. So that we can write it as, that we can write an identity function iy. That means if I go for composition of a function and the corresponding inverse function is coming always identity function. This result you have to remember it. That is, composition of a function with its corresponding inverse is equal to identity function. This is one of the results. Okay. Now we will discuss another result. We will discuss about another result, that is a function inverse what it will be? Inverse, that is f inverse whole inverse what it will be. A function's inverse and whole inverse what it will be. So see the arrow diagram. If we consider the arrow diagram, a function is defined, that is the function f. It is 1 1 and 1 2. Naturally f inverse is here. F inverse is here. So if it is an x here, its corresponding image here y with respect to f. Now if I apply f inverse on this, it will come to this here f inverse. So it will come to the image will come here. Now once again if I go for its inverse, so it will be like this. Again we will take the direction, take the reverse direction. F inverse of f. So it is coming to y. Originally I started to x to y. Then y become x, then again what happens? X becomes y. That means what it is? It will be same as f. It will be same as f. That is f inverse whole inverse is equal to f. So this is one result. Provided remember that f must be always 1 1 and 1 2. That is f must be bijective. Then only all these things are applicable. Okay, so this is another result. Or if you write just like element form. If you see this element of f is x comma y, and element of f inverse is yx, then element of F inverse whole inverse. F inverse whole inverse again it takes direction, so it is XY. It is same as F. It is same as F. Like this also you can say it. So that is F inverse whole inverse is equal to F. This is one result. So this is, you have to remember it. Now one more result. One more result. You have to know it. That is a result related to the composition. Suppose a function f is from a to b is 1, 1 and 1, 2, that is bijective, and g is from b to c, it is also bijective, both are bijective, that is this is also 1, 1, 1, 2, this is also 1, 1, 1, 2. There is a composition, we know g of f. G of f is from, we know it will be from a to c, this is also will be bijective. This bijective, then this is also will be bijective. And one more result regarding inverse, g of f whole inverse is equal to, this is equal to f inverse of g inverse. See, it is interchanging. F inverse of g inverse. This result also you have to remember it. That is, we can see just like a reversal law of inverse. Reversal law of inverse we studied in matrices. In determinant part you studied. So the same result is coming here. G of f whole inverse is equal to f inverse of composition G inverse. So these are the results you have to know in this part. Now we can do the sums based on this. So here mainly the questions comes, you have to find out inverse. For finding inverse, first of all you have to prove that the function is 1, 1 and 1, 2. And how to prove 1, 1 and 1, 2 you come across already in one exercise. How to prove 1, 1 and 1, 2 you already come across. So same method you have to apply it, and finally we will write the inverse. So that is the question. So that's such type of questions only here we are going to discuss. Now we will see a few questions. There are so many questions. It is all similar type, and you have come across already most of the such type of sums in the earlier exercises. So exercise 1.5. From exercise 1.5, I will do first of all question number 1. It is given the function f is defined from 1 to 3 to ABC. The function that is the set x and y, just like the function defined from x to y. Be a function defined like this, it is given f of 1 is equal to a, f of 2 is equal to b, f of 3 is equal to c. There is an element and the corresponding images is given like this. Now you have to show that f is invertible. You have to show that f is invertible and find f inverse. Invertible you have to show it, and then you have to find out its inverse. Also show that f inverse or inverse is equal to f. Three things you have to do it. First of all you have to prove that it is invertible. For proving it is invertible you have to show that it is 1, 1 and 1, 2. So here it is easy to do with help of a Venn diagram, and from Venn diagram we can write it. A Venn diagram is arrow diagram. From arrow diagram we can show it. So that will be easy. See, if I name it as the sets, let it be this set x, this is y. Elements of x is given 1, 2, 3. Elements of y is given a, b, c. The function is defined like this. F of 1 is equal to a means. So this is connected with there. F of 2 is B, F of 3 is C. Now if you observe this arrow diagram, it is clear it is 1, 1. See, all the elements are connected with only one element, so it is 1, 1. And here no element is left over, so it is 1, 2. So clearly we can write it clearly from the arrow diagram. The given function is 1, 1 and 1, 2. Hence it is invertible. You can write like this. Clearly from the arrow diagram, the function f is 1, 1 and 1, 2, hence it is invertible. That is the first part. And second part, you have to find out f inverse. F inverse we have to find out. So f inverse, first of all we will write the elements of f, then it will be easy. Elements of f clearly we can write from here or from here. Elements of f is 1a, 2b, 3c. These are the elements of f. Then f inverse. F inverse, we have to take its reverse, that is A1, B2, C3, A1, B2, C3. These are the elements of F inverse. So this is the second part, and we have to do one more thing also, show that F inverse whole inverse. F inverse whole inverse is equal to F. So what is F inverse whole inverse? We will once again we interchange the order. So it is 1A, 2B, 3C. Now if you observe this F inverse, whole inverse and F, it is both the same thing. It is both the same thing. So we can say this is equal to F. So F inverse, whole inverse is equal to F. That is the third part of the question. So this is question number 1. Very simple question. We are done mainly with the support of arrow diagram and written elements in what is called ordered diagram. Like that we are done it. This is one type of sums. Now another type, the function may be given in different ways. So such type of another question we will do. Question number 8 we will do it. There are many questions of like this from the exercise. Practice, then you will come on right. Now we will do question number 8 from the exercise. Question number 8. Here the function f is defined r plus to 9 infinity, it is given in interval form. R plus means the positive real numbers. Here the closed interval 9, that is 9 is included, infinity that is excluded. So that is the function is defined from r plus to this one. So we have it is given defined like this. Fx is equal to the function defined like this, x square plus 9. We have to show that f is invertible, also find f inverse. So first we have to show that it is invertible. Invertible means you have to prove that it is 1, 1 and 1, 2. 1, 1 and 1, 2. So you know how to do 1, 1 and 1, 2. We have done in the previous exercise. So first of all 1, 1 case I am trying for 1, 1. So for 1, 1 what you have to do is we will go like this. We will take two elements from here, x1, x2. x1, x2 from this. For 1, 1. Let x1, x2 belongs to R plus. I taken from the domain two elements such that fx1 is equal to fx2. Our 1's method is like this. So we will substitute and will simplify x1 square plus 9, x2 square plus 9. I substituted x1. 9 cancel. I am bringing to one side x1 square minus x2 square is equal to 0. This I can factorize x minus 1, x1 minus 1 into x1 plus x2 is equal to 0. Now, by the zero product rule, if you apply it, this is equal to 0, this one is equal to 0. But if you observe x1 plus x2 cannot be 0, since x1, x2 belongs to positive real numbers. Positive real number, two positive numbers if we add, we never will get 0. So that means this part cannot be 0. So we can say x1 plus x2 not equal to 0. It cannot be 0 because x1 and x2 are positive real numbers. Then this implies x1 minus x2 is equal to 0, implies x1 is equal to x2. So it is 1, 1. So we got the function is 1, 1 plus. We got it 1, 1. So for 1, 1 we go across like this. So from this we will be getting x1 is equal to x2. So it is 1, 1. So you are done like this sums in the previous exercise. Now we have to go for on to. For on to. Okay, one more part is over. Now for on to. For on to, if you can do codomain is equal to range, codomain is equal to range, then it is what we can say is on to. So here clearly function is from here to this. So codomain we can write first of all. Codomain I am writing, it is given this codomain is equal to 9 to infinity. Now let me see what is the codomain from this. Okay, so the function is given this. I'm writing y is equal to x square plus 9. So from here y minus 9 is equal to x square. Y minus 9 is equal to x square. Now we know x square is always greater than or equal to 0. X square is always greater than 0 because x belongs to this. Square of any real number will be always greater than 0. So we know x square is greater than or equal to 0. This implies y minus 9 greater than or equal to 0. That is y greater than or equal to 9. That means we can say range. From this we can write the range is equal to range of the function is equal to from 9 to infinity. Range is equal to 9 to infinity. That means we can say range of f is equal to, see, range of f is equal to codomain. Range of f is equal to codomain. Therefore, we can say the function is onto. Therefore, f is onto. So we got the function is 1, 1 and 1, 2. I put range is equal to codomain, so the function is 1, 1 and 1, 2. Therefore, we can say the function is invertible. So that is the first part. We have to prove it is invertible. So invertible part is over by proving 1, 1 and 1, 2. Now we have to find out the inverse of the function. I think yes, we have to also find f inverse. We have to find out what is f inverse. So f inverse we have to find out. So for finding f inverse, we have x square plus 9, that is y is equal to x square plus 9. From this y minus 9 is equal to x square, or x is equal to root y minus 9 is equal to x. And in the definition of inverse part, I have said there are certain points I said. What is called x is equal to, I said like this, x is equal to f inverse y. We have a result x is equal to f inverse y if and only y is equal to fx. We have results x is equal to f inverse y. So if I use this x, I can write it as f inverse y is equal to root y minus 9. So this is the inverse f inverse. F inverse of y is root y minus 9. In case if they ask what is f inverse of x, then you write here root x minus 9. So here question is find f inverse, so I wrote f inverse y is equal to root y minus 9. This is question number 8. Now one more sum we will do it from the same exercise, one more sum, that is question number 19. So only the new thing is for f inverse. So 1, 1 and 1, 2 you have come across already. We have studied in one exercise in detailed way. So I am not giving stress on 1, 1 and 1, 2. First of all, I am finding mainly f inverse. Okay. Now one more sum, question number 19 from the exercise. Question number 19. Here the function f is defined from r minus 4 by 3 to r minus 4 by 3. The function defined from this set to this set. This question 19, if you come across, I think there is some error is there in the book. So this is the corrected form. Okay, f is from here to this function. Okay, defined like this: fx is equal to is given as 4x by 3x plus 4. We have to find out f inverse. Question is find f inverse. So first of all, you have to do it is 1, 1 and 1, 2. F inverse, first of all, so that is bijective 1, 1 and 1, 2. So first of all, just like before 1, 1, earlier we have done 4, 1, 1. I am taking two elements from here. x1, x2 belongs to the domain of f I taken. That is except this number, any real number. That is what x1, x2 from that. fx1 is equal to fx2. Our normal algebraic simplification, we come across all these things, so we can do it very fast. All these things, since you already you know these things, how to prove 1, 1. If you have doubt, go through the previous videos. Cross multiply it, 12x1 x2 plus 16x1 is equal to here 12x1 x2 plus 16x2. Yes, 12x1 x2 cancelled. These two if I group it, these two part if I group it, that is 16x1 minus 16x2 is equal to 0, or we can say x1 is equal to x2, so the function is 1 1. The function is 1 1. So the function is 1 1, that is the first part. Now I have to go for on 2. So 1 1 part, this is all normal simplification you come across already in the previous exercise. So this is 1 1 part is over. Now I have to go for 1 2 part. 1 2 part. Y is equal to, so first of all if you want you can write codomain. 1 2 part. First of all codomain, this is codomain. This is the codomain. Codomain is equal to R minus 4 by 3. Now this one I am finding from here 4x by 3x plus 4. I am finding the corresponding y values. Cross multiply 3xy plus 4y is equal to 4x. I am making x subject, x I am making subject. So 4y is equal to x I am making subject. X 4 minus 3y. From this x is equal to 4y by 4 minus 3y. So if you observe here y, you cannot take the value of y is 4 by 3. So y cannot be 4 by 3 from this. If you observe this, you come across our domain range or such type of part. From here we can say y cannot be 4 by 3. That means I can say range of this function is equal to r minus 4 by 3. R minus 4 by 3, y cannot be 4 by 3. So r minus 4 by 3, if you observe this is same as our codomain. This is equal to codomain. This is equal to codomain. That means range is equal to codomain. So the function is on 2. So the function, since the function is 1 1 or 1 2, 1 1 or 1 2, we can say that f is invertible. We can say f is invertible. Now if it is invertible, we can write down its inverse. Since it is invertible, we can write down its inverse. Okay, how to find out inverse? Already we come across, we reached here one result is there, x is equal to 4y. This result is there. From this itself, we can write just like a previous one. This x, we know it is f inverse y. X is f inverse y. So f inverse y is equal to 4y by 4 minus 3y. This is the corresponding inverse. This is the corresponding inverse. The main part of the question is you have to prove it is 1 1 and 1 2, and then we will get the f inverse.